Thank you so much for joining us today for this exciting discussion around how innovation can support clean energy transitions, particularly in developing and emerging economies. We have a great lineup of speakers that will share insights with us around what can be done to foster innovation in this area. And we have on-the-ground innovators that will share with us experiences and insights. This session is being recorded, and please do use the question and answer option to not only ask questions to our speakers, but to also share with us your insights and your suggestions on this topic area and what further exciting areas that we could jointly explore with you. With that, it's my great pleasure to hand over to Dr. Brian Motherway, Head of the Energy Efficiency Division of the International Energy Agency. Brian, the floor is yours.
Thank you, Vida. And good morning, everybody. It's great to welcome you to this event. I think it's a really important subject we're discussing this morning, this morning in Paris time. And I'm delighted that so many great speakers and so many of you have decided to join us for this session. The first of two we're doing on this topic today. So we're very pleased, very grateful to all of our speakers. This comes at a really important time. Of course, we all have our focus on accelerating towards clean energy transitions, but we're also living in the grave times of the great humanitarian impact of Russia's invasion of Ukraine, which is focusing minds not just in Europe, but around the world on resilience, energy systems, the need to reduce our dependence on fossil fuels, and the need to really accelerate progress towards our energy systems of the future. And of course, digitalization is at the heart of this. So what digital can do in terms of energy control, demand side flexibility, optimized energy use, all have more and more value than ever before in today's world. And if we're to achieve the potential of digitalization to really improve our energy systems, reduce our costs and improve our resilience, well, a number of things are needed. First of all, we need stronger frameworks from governments in terms of policy, regulation, market design, but possibly even more than that, we need the innovation in terms of technology and business models that you're going to be hearing about today from some great companies that are really doing fascinating things in various parts of the world in terms of what can be delivered by emerging technologies in digitalization. So we're very pleased to have all of these great speakers today, and I want to thank them. I also want to thank the Italian Ministry for Ecological Transition, who have been supporting our work here at the IEA through the IEA's Digital Demand-Driven Electricity Network, so 3DEN initiative, that sets the context for the work we're doing today in terms of digitalization, power system modernization, and clean energy transitions. I'm also very grateful that we're co-hosting today's events with Energy Systems Catapult. We're delighted to be working very closely with them, and I particularly want to thank their director, Laura Sanders, who's joining us here this morning. So I hope the event is as rich as I think it's going to be in terms of the great speakers we have. I look forward to listening to it all, and thanks again for joining us. Back to you, Vida.
Thank you so much, Brian. And as Brian mentioned, this is an event we are co-hosting with Energy Systems Catapult that has been working tirelessly to explore and define and identify what are the frameworks that can help stimulate innovation in this space. So it's my great pleasure to hand over to Laura Sanders to give us a brief introduction of the great work that they're doing. Laura, please, the floor is yours.
Thank you so much, Vida and Brian and the team at the IEA. It's a great pleasure that we're co-hosting this event. If I have my slide, that'd be lovely. I am Laura Sands, a non-executive director of the Energy Systems Catapult, and you will be hearing very much more from my colleague, Richard Dobson, who is really the brains behind the digitalization drive on behalf of the UK government, but hopefully useful examples about in many ways for other markets. So next slide, thank you. And if you press on a bit, thank you. So what does the new world look like? Well, we are going into a much more complex energy experience. For old economies like the UK, we're having to do a lot of retrofit. I'm sure there are lots of people on this call from all parts of the world that actually have the opportunity to leapfrog some of the incumbent thinking that we've got here in the UK, which is really, really exciting. And I really look forward to actually seeing those innovations come through, and hopefully markets like the UK being able to learn from you all. But if we look at the energy sector in the UK, for example, there are 400 people who run the energy sector, more or less. They all know each other's golf handicap. We're now moving to 100 million actions and assets on this system, whether that be EV cars that can do two things, whether it be storage assets, looking at sort of self-generation, all of these multi-purpose and multi-vector actions are going to need to be managed and optimized. And let's look at this world of the renewables world, and that is weather will not take price signals. It doesn't follow legislation. So all the balancing, particularly of the electricity system, is going to have to be done on the demand side. And that is a really new thinking for the So as we move into this new world, sorry, to move on to the next slide. We are not going to be able to do this in an analog way. Currently, it's ringing people up and getting people to ramp up. Now, if you look on the left, we are playing blind man's bluff at the moment. The quantities of action, the diversity of interactions is going to be absolutely huge. The opportunity of digitalization and open data will be that we can optimize the system. We can release value and we can release those customer rewards. But as we all know, storage and flexibility is going to be absolutely crucial and will sit right the way through the energy system. And this is only going to be able to be delivered by digitalization and what I would call deep digitalization. So next slide. So maybe some of these themes will come out of, as we have this seminar, but I see certainly that there are sort of three drivers of change. Net zero is not a consumption model. It is much more about optimizing resources, assets, and utility of the energy system. We've got to look at whole system costs, not just this commodity, because the system is going to cost more and more. And as we've seen in data, where the cost of data was very expensive in the 1990s, has now reduced significantly, we're going to see it's actually the system costs in the energy sector that we need to really focus on, not just the commodity itself. And that, as I said, weather doesn't take price signals. So demand is equal to supply, not necessarily in scale, but certainly in value. And so what do we need? We need digital transformation of the sector to optimize the whole system. Data and digital principles, interoperability is going to be absolutely crucial, but we need to do that through open data and open source software. New business models, that's what we're talking about today. In many ways, some of these technologies and the digital platforms exist in other sectors. It's how do we transpose those into the energy sector? And as Brian rightly said, new regulatory frameworks. And I hope that we're going to see a lot more new actors into the sector. So it's a very, very exciting time for innovation. We've got a fabulous group of people here today. In many ways, it's down to you, the innovators, to make these changes. And for us as people involved in policy is to assist the market to unlock them, to make them real for you. So really looking forward to the two seminars today. And thank you very much for offering me the opportunity to give a little bit of a tour of the future. Thank you, Vida.
Thank you so much, Laura. As always, very inspiring to hear your thoughts. So what I'd like to do now is to hand over to my colleague, Simon Bennett, who's been leading work on looking at what are the best practices when it comes to innovation and supporting innovation. What are some of the exciting things that different countries are doing? So with that, I'll hand over to you, Simon.
Great. Good morning, everybody, or good afternoon to some, and thank you to Vida for the introduction. I mean, that's exactly right. We've been looking recently at the policy environment around technology innovation in particular. And this is great timing. So I'm delighted to be able to join you to present a report that came out only last week. So this is somewhat hot off the press. And I have, once the slides come up, we'll be able to see that, I've included our sort of full set of slides, but I'm going to try to talk relatively briefly through some of the main points that I think are of interest to this audience today. And I'm not here to say, how important digital technologies are to a clean energy future. I think that's something that everybody on this particular call knows very, very well. What I think is less well known is how interesting some of the developments in the policy side to get these smaller scale and digital technologies into the market have actually been. So we're actually, in the way that we look at the long-term energy future, we're at a point in time where the nature of technology is changing. And I think everybody here knows a lot about digital technologies and smart technologies, but there's something about the increasing role of technologies that are consumer focused, that are modular, that are small scale, that are electronic in nature rather than chemical energy related in nature, that's actually leading to a situation in which there's a greater chance for smaller companies, for startups and innovators to make it from the lab to the market and to grow sort of high growth potential unicorn companies, the Teslas, the BYDs of the world, from relatively humble beginnings. And if we look around the world, we see governments really wanting to support them and bring them to market because of the economic potential as well as the environmental benefits that could bring. But at the moment, there's no great place for governments to go to see what the resources could be for that. Yeah, let's go on to the next slide, Vida. So we noticed that there's no resource for governments to look at the choices here, and the creativity that I think exists in the policy space is something that's definitely worth sharing, just at the same time as the creativity in the technology and the business model space. So we wanted to do two things. We wanted to let everybody know about that situation and just how interesting the space is at the moment, but we also wanted to create a sort of a guide or a handbook for governments to look at some of the options that they face, because what we discovered is that when you look at the barriers that many of the clean energy startups are facing, there's as many policy options as there are barriers, and when you combine the two together, you've got an almost unlimited number of choices for governments. So the report that we've put out, it's called How Governments Support Clean Energy Startups. It's based on a wide range of interviews and some case studies and some other policy highlights. And I think that it's also of particular relevance to this audience because we found that some of the policy leadership and some of the technology leadership, in fact, is not coming from the traditional sources in advanced economies. We found some great examples in Singapore and India and in Chile as well that we've brought to light in this report. We worked with a framework that we mentioned here, and if we go on a few slides, then we'll be able to see the framework. I think maybe forward, yeah, we'll skip the charts, we'll skip this background information, yeah, and we'll stop here because it's interesting to note we structured the report around 4 services that startups need, at all of the different stages of the life cycle from lab to early market penetration. And I hope that these resonate with our panelists today. It's certainly something that we heard from those that we interviewed. And we made a particular distinction between the type of support that governments are providing in a direct way. And most of these different things that you see on the screen can be provided by governments themselves. So we can have civil servants managing grants, we can have them managing even sort of incubator functions, but we can also see them provided through third parties. And that was something of an eye-opener to see there's even more choice than we'd realized, and how when it comes to different types of technologies, some things begin to look more appropriate than others. And in the area of smart and digital technologies, there's some really nice examples of entities, think of the clean energy International Incubator Center in India, or the Ecolab COI in Singapore, that are focused on smart technologies, that's focused on consumer end of the electricity puzzle, and they're actually providing this whole range of services because they're not particularly infrastructure heavy. You don't need costly laboratory support. You don't need to have a wide range of the capital intensive infrastructure solutions for those startups. And so they've been able to provide some end-to-end support, and we've seen some of the startups actually now emerging onto international markets. So if you go to the next slide, you'll just see a range of the initiatives that we featured in the report. And as I said, there's this matrix approach with direct support, indirect support, financing, infrastructure services, and networking areas in the ways that the support can be provided. And not all of these initiatives, these programs that we saw, us providing all of the elements of support. Some of them are focusing on the particular needs in the particular sectors or regions in which they are active. But what's interesting is that when you look across this landscape, you actually find that almost all of these have been started since 2015. It's a relatively new area for governments to be combining some of their experience in helping venture capital markets and the technologists that are bringing products to market, and the experience that they have in supporting energy research and development, and then bringing these two policy areas together to meet the particular needs that clean energy startups tend to have in terms of their longer life cycles of development, their higher needs for hardware support in particular, although sometimes that isn't always applicable to the digital firms, which means they're not necessarily compatible with typical venture capital life cycles, which means that they have a different relationship with debt often because of those timetables, and that governments actually have resources that are very, very appropriate in many cases for the energy community in terms of national laboratories and connections with many of the energy intensive infrastructure and companies that are active. And of course, I need to highlight that we included Catapult, the Energy Systems Catapult, as one of our case studies in the report, because of a particular program that they have to enable smart energy companies that are on the efficiency side of the equation to operate in a network of connected residential environments in order to be able to test their technology and do so without having to go through the enormous potential contracting costs of being able to get into people's homes, workplaces, to be able to see how their technology performs in the regulatory environment. And Catapult is giving them a big boost in order to do that. So that was one of the examples. If we go to the next slide, if we go to the next slide, we see the list of our 14 particular case studies, but we don't need to dwell on that because that's all in the report. But the next slide has just a sample that we've pulled out because they have particular policy creativity in our view. The one in the top left is in Morocco, and it has a financial creativity in the way that the startups, as they enter the program, can make their own choice between whether they take on grants or equity financing, whether it's dilutive capital or non-dilutive capital. American-made challenges in the bottom left is just a great example of how the US Department of Energy has designed prizes that actually are not huge in terms of the financial resources, but target particular technologies that they're interested in and help the young startups to go through different stages if they are successful at each stage to win a larger prize, and vouchers for access to Department of Energy laboratories, which is a resource that simply isn't available to most startups. So if that's in a country in which startups are operating, then the government can step in a big way. And the other one I'll just mention is Startup Energy Transition. This is a German program. Again, it's prize-based, but they target a much wider range of technologies with each of the prizes they launch on an annual basis. But for relatively little prize money, they provide a huge amount of publicity to the startups that are able to get into the top 100 and then get into the winners category. And those startups that win the program are brought into direct contact with policymakers and government to work hand in hand on some of the regulatory challenges. So I'm going to finish my short presentation just with the next slide, which outlines what our 8 insights for effective policy in the report are. And I'll stress again, I think particularly in the emerging and developing economy context, this number 1 insight, which is to maximize what you already have. Governments around the world, and I know that I'm not speaking only to governments, but I think that this is true in general. There are entities out there, including governments, that already have the laboratory support, the deep expertise, the reputations and the networks that can be mobilized in favor of many of the key innovators that we need in order to accelerate the pace of energy innovation and reach our future environmental targets. And then I'm going to highlight insight number 2, because taking a global outlook and cooperating between countries can also allow this acceleration to be facilitated at lower cost. And we saw a great example where the startups that are in a program in Singapore can interact with the startups that are in a program in Canada and one that's in a program in India. And actually some of them travel to Singapore on an annual basis in order to receive incubation support from a government-sponsored entity and then get access to markets around the world. So those are the key ones that I've pulled out here, but please do go read the report and look at the full list of 8 insights that we've included there. So thank you for your time, and please get in touch if you have any questions.
Thank you so much, Simon. As Simon was saying, the report is freely available on the IEA website. Do have a look. It's full of great examples, great case studies, and interesting insights. And now it's my pleasure to hand over to Dr. Richard Dobson, who will tell us a bit more about the work that Catapult are doing and the insights that they've gained through this work. Richard, please, the floor is yours.
Brilliant, thank you. You could just jump on to the next slide, please. So I guess first to start saying, I'm Rich Dobson. I'm from the Energy Systems Catapult. We're a not-for-profit, government-backed research and innovation organisation in the UK. And I'm very happy to see the Living Lab being called out in the previous report as well. The piece of work that I'm going to talk about now is about the Energy Digitalisation Task Force, which was a government initiative where they asked for some independent expertise and advice in the area of digitalisation of the energy system. Laura Sands was brought on to be the chair of the task force, and the Catapult acted as the organisation to help run and support the delivery of that. So if we could just step forward, please. That's great. So I guess first thing to say is that we have a track record of doing this kind of thing in the Catapult. A few years ago, we ran the Energy Data Task Force that really focused on looking at where specifically data could help with the energy system. And that was really looking at data visibility and also infrastructure and asset visibility, taking a very international approach, looking at best practice globally and trying to sort of consolidate that in the UK to see what impact that could have if you did all of the best practice things in one place. That was published almost 3 years ago now, and has been a pretty resounding success. We've had a lot of impact off the back of that, particularly policy and regulatory change, and some really good recognition that this is the right direction to go, plus a lot of delivery support from industry and the sector more broadly. The Energy Digitalisation Task Force looked to build on that specifically focusing on how digital technologies could impact the energy system, going beyond just purely utilizing data sets. So we're really thinking about getting the right digital infrastructure and right digital culture in place to enable operational optimization, open system design, and really try and give us the best chance of having a digitalized, decarbonized energy system that actually delivers what we need. You could step forwards, please. So the aims and approach of the task force was to really focus on this modern, decarbonised, digitalised energy system. But we focused on 4 key outcomes. And this was our idea of what would success look like. So we believe exciting, tailored customer propositions. So actually selling customers things that they need rather than units of energy. Making sure that we have a stable and resilient energy system. That's retaining it in the UK, because we're privileged to have a relatively stable and resilient system, but how do we make sure that doesn't get compromised going forwards with the use of high levels of intermittent renewables and other new emerging technologies. Accelerating decarbonisation was absolutely at the heart of it, and that's part of what's driving the UK government policy agenda right now. And then also thinking about whole system optimization. And this really speaks to what Simon was just talking about, of making the best use of the assets we already have in place. It's not about rip it all out and redesign. It's how do you optimize for the system you have and make it the system you need in the future. If we could jump forward just to, I think, 2 or 3 slides. One more, please. Perfect. So to cut to the point, within the task force, we produced 6 key recommendations. And the idea was that these were some of the most important things going forwards that we felt would really help to unlock the value of digitalization within the energy system. So the first one was about unlocking the value of customer actions and assets. And this is really recognizing that there are many energy assets across the system, which could be a much better, much more productive part of the energy system. And particularly speaking to innovators, we found that whilst they had the great ideas, they had the technology solutions, in many cases, they were being hampered by some policy, regulatory, and also technology infrastructure challenges. So we put forward a number of actions within that recommendation that would help to unblock that. First and foremost was the customer consent dashboard in the UK. We don't have a centralised smart meter data repository, and we don't have a centralised or consolidated way of dealing with customer consent. That is a real challenge for innovators because it means that they are managing quite a complex, messy environment. Secondly, we also suggest that the government should mandate smart energy assets, making sure that as we install new energy assets, they are smart, they are digitally connected, and they can therefore be part of a productive, flexible energy system going forwards. This is particularly important as we're on the edge of offering subsidies for heat pump installations, many hundreds of thousands over the next few years. And also we are investing hugely into flexibility in the UK. So we need to make sure that we are capturing assets that could be flexible on day one rather than retrofitting. The second recommendation was about delivering interoperability. We see this all across the energy system, actually, that interoperability is key, but specifically focusing on digitalization, we found that there were many cases where digital silos are emerging. So we made a series of actions behind that, but the primary one was about developing a digital spine. And this is essentially a distributed system monitoring solution, very similar to the approaches that are used within cloud computing environments and global scale data center operators, but really trying to apply that technology in the energy sector. And that's a really interesting, innovative thing that we think would actually help to make a big difference in the system. Third recommendation is about implementing new digital governance approaches and entities. This is really important because digitalization has lots of benefits, but it also has many risks, particularly for vulnerable customers. So it's important that we have a way of ensuring that they are protected, but also we have a way of delivering effectively and making sure we're delivering on time, on budget, and actually delivering what is needed. Of course, we had to talk about digital security measures, and we consulted a number of cybersecurity experts to make sure that we were putting forward a set of actionable recommendations here that could be taken forward by the sector. The fifth recommendation is about enabling carbon monitoring and accounting, and this is really trying to make carbon data that does exist much more dynamically published. So rather than waiting for an annual ETS statement, we're actually looking for organisations to publish in line with settlement periods, and this would be incredibly valuable going forwards, and also putting in that digital technology to make sure that we are monitoring the black holes that exist today. And finally, and by no means least, embedding a digitalisation culture. The energy sector is absolutely privileged to have a number of highly skilled, very intelligent, very capable engineers who know how to run energy systems. We're bringing in digital skills and digital expertise, but they have a very different way of working to the incumbent sector. So it's really about trying to blend those two, well, more than two sets of experts into a sector and making sure that they can deliver the best outcome for all. So this isn't about kind of overrunning the sector with kind of digital ways of working, but it's about trying to find that right balance between the energy sector's way of working and the digital sector's way of working. I think I'll pause there, and then we can kind of move on. Thanks.
Thank you so much, Richard, for sharing these insights, these recommendations. And now it is my great pleasure to hand over to my colleague, Emmy, who will be moderating the next discussion. Please, Emmy, the floor is yours.
Yeah, thank you, Ida. So good morning and good afternoon, and thank you all for joining us today. So I'm Emmy Bertoli, Policy Analyst at the Energy Efficiency Division of the IEA. And as Ida mentioned, I'll be moderating this session. So we will start with a short introduction by our panelists and then move on to a panel discussion and Q&As. So I would like to welcome our panelists for this session. We have Rahul Shelke, Managing Director of Ampere Hour, Ryan Park, Strategy Lead of Gridwidth, Nithya Menon, Head of Products at Okra Solar, and Linda Maria Badman, Chief Marketing Officer at PlexiGrid. And now I will hand over to Rahul for a brief introduction. Rahul, the floor is yours.
Thanks, Amy. Hi, everyone. Good morning and good afternoon. So, can you go to the slide, please? The first slide. Yeah. So, for this webinar, I'm presenting majorly on the power system digitization and how the use of digitization can happen in the power system to make it more resilient. Here, just a small brief about the company Ampere and the use case, what we have done into the power system digitization and how we have used our energy management system platform for actual use case in India. Can you go to the next slide, please? Yeah, so the Ampere Energy has two products. So first is an artificial intelligence based software platform, which is we call it an Elena, which works on for all the applications of an energy storage. It works for generation, transmission, distribution, and all other fields like commercial, EV, and off-grid systems. Here, I am more focusing on transmission and distribution. And the second product, what we have is a complete energy storage, which is a low-cost, battery-agnostic, and modular and scalable energy storage platform so that we can use it at all the levels of transmission and distribution and generation. Next slide. So what is the problem like for the countries like in India? What is the practical challenge for a distribution system? So the these are very load growth kind of countries, and all the distribution infrastructure is in very congested areas. The cities are all populated a lot, and that's the reason the distribution infrastructure is in the middle of congested areas. There are frequent transformer downtimes or the distribution downtime because a lot of increase in the per capita energy consumption or increase in the number of users. Also, there is a huge amount of solar, wind is done in India, preferably in distribution. There is a lot amount of solar rooftops is done. In India, it's 6.7 gigawatt of rooftops are installed over only the residential and commercial sector. And addition to that, there are a lot of EVs are coming on the ground, and which is also increasing the distribution loads. So all these problems been solved by putting up an energy storage on the distribution transformers. And our software, which is an ELINA, which is actually controlling all these individual ESS systems in order to solve these problems. Can you go to the next? So the solution which we have provided is India's first multi-transformer based virtual power plant. It is located in the north of India in Delhi. And there are 6 energy storage systems are placed at the different transformers. And what kind of application we are doing is network level uninterruptible power supply. If the transformer fails, you get the power so that your consumers get maximum availability of power. Then the peak shaving, whenever there is a higher load on the transformers, energy storage gives the power and it reduces the load on the transformer so that transformer replacement can be avoided. Energy arbitrage, whenever there is a lower loads, that time we charge the batteries, and whenever there is a higher loads or the higher tariff, then we discharge the energy storage. So that gives another benefit. Then the power factor regulation, because as these are placed in the commercial and residential premises, there is a huge power factor kind of issue. So this is also solved by an energy storage. And a central algorithm for all these 6 DERs or ESS in order to control that as a single energy storage, as a single virtual power plant. So that has been controlled by a single SCADA or the single load dispatch centers. Next slide. So the services which are offered are energy arbitrage, peak shaving, power factor improvement. So here you can say that the peak load shaving is offered on the local level of ESS. Intelligent energy dispatch to reduce the cost of energy purchase is offered on the central level, which is controlled through VPP. Power factor improvement is offered at the local level. All these issues been solved by the single solution of software and the hardware. And the software, like all the assets are digitized, and the softwares are like safe for cyber attacks and all. Next slide. So there are some additional use cases which we are now which are coming or which are coming in future, 1 or 2 years, which are intelligent energy dispatch in order to reduce the DSM, like distribution or deviation settlement penalties, which are based on the frequency and the voltages. So all the utility or the distribution companies have that kind of penalties, which can be solved by actually charging and discharging an energy storage through VPP. There is another like utilization of energy storage kind of document is passed by the government for giving an energy storage at generation, distribution, transmission, and all level, and giving us energy storage an opportunity to play in the market for the ancillary services. So the Drupe-based automated frequency and voltage regulation is also another use case which is coming. Next. So the ELINA, the software which I was explaining, it's a complete system. It's a digitization of distribution system, transmission system. It is inbuilt with the optimization algorithms. It can integrate with any SCADA platform, in any DMS or SLDC, on any protocols like IC 61850 or 104 or DNP3. And our EMS can be configured over the air. So there is no need of actually going to the site and all, and it can be serviced over the air as well. And it's a seamless user experience. And we are deployed that at 250 plus places in India. Next slide. So how the future grid looks like when we place an ELINA over there. So the ELINA is a central energy management system, which is controlling, or which is talking to an energy prices, which is talking to weather data, which is talking to the flexible generators, all rooftops, biogas, waste treatment plants with the dispatchable power. It is talking to an energy storage, which is installed by us or installed by third party. It is talking to the flexible loads in order to create a digital power system so that grid resilience can be achieved. Next slide. Thanks.
Okay, thank you very much for the insight, Rahul. Up next, Ryan, the floor is yours.
Hi, good morning, everyone. My name is Ryan. I'm a strategy lead at Gridways. Can you jump to page 4? Yeah. So Gridways is a startup based in Korea. We provide an intelligent software platform integrating currently gigawatt scale distributed energy resources, including demand response, energy storage, rooftop solar, and EV battery to provide flexibility to the grid. So at this session, I will briefly introducing the interesting project we are currently working on in Jeju Island. In this case study, you will see how we are using the EV batteries as flexibility resources to help the grid problems. Next slide. Next slide. So for those of you who haven't heard about Jeju Island, it is the biggest island in Korea that has a separate grid system from the mainland. Currently, we are seeing the most rapid renewable energy expansion in Korea, which is also causing the severe curtailments of wind powers. So next slide. Next slide. So what we did in here is we used a network of EV batteries as a virtual power plant. So when electricity demand is low and renewable energy availability is high, the drivers who sign up for the demand response program through our Sky Blue platform allow their vehicle to be smart charged and earn incentives for charging their vehicles. By participating in such program, driver could get about $300 per year incentive, which could reduce charging fee by 25% annually. So in this case studies, our platform aggregates EVs and also remotely control EV charging based on system operators' demand response signals. So in this case study, we successfully demonstrated that EVs can also serve as a reliable and flexible grid asset, which could eventually save money for both system operators and EV owners. So I believe that EVs represent an enormous opportunity for grid services. EVs can be smart charged in response to help grid stabilities. So right now we are also collaborate with other energy players in a lab setting to explore vehicle-to-grid, so-called V2G technologies that enables EV to discharge electricity to the power grid. So due to time limitation, this is it for my presentation. So if you have a question, feel free to ask later. Thank you.
Thank you very much, Rayan, also for keeping it straight to the point. So I would like to welcome next Nithya. Nithya, the floor is yours.
Great, thank you. Yeah, we can go ahead to the next slide. So yeah, starting at the big picture, and many of you probably already know this, but there are still 760 million people who live without access to electricity, and instead they rely on things like fossil and high pollutant fuels, which are not only incredibly expensive in these hard to reach communities, but it's also destructive towards people's health and of course the environment. Next slide. Traditionally, the technology to get electricity to these off-grid communities have been AC mini-grids. However, this infrastructure is inflexible and becomes prohibitively expensive when you're trying to distribute power between spread apart, randomly dispersed houses in remote areas. And these costs result in anywhere from 10 to 20-year payback periods, which fail to provide a bankable solution. Next slide. At Okra, we saw an opportunity to reimagine what off-grid energy infrastructure looks like. Firstly, fuel is becoming increasingly unaffordable, especially in today's climate. And secondly, we've seen a 70% reduction in panel and battery prices in the past decade, both of which are inherently decentralized assets. And then third, the increases in connectivity around the world, while not 100%, are getting close and have unlocked technologies like IoT and automation, which make it possible to control and manage remotely distributed assets in entirely new ways. So leveraging all of this, we can present a new grid solution that's been optimized for the off-grid landscape. Next slide. This new grid architecture is what we call mesh grids. So mesh grids are a lower cost and more modular solution designed to meet the constraints in last mile communities. So for one, they're easy to install. Our IoT controller with panels and batteries are installed on individual homes. And then homes that are close enough together can be connected into these smart clusters, at which point our algorithms in the controller redistribute excess power to wherever it's needed most. And by being so modular, they can be scaled and grown and expanded over time, while providing high output power to households to enable them to consume, to use productive appliances and gain opportunities from electricity. Next slide. Our power distribution algorithms optimize so power doesn't have to travel as far, which means that the mesh grids can use 1/10 the cable size of mini grids, and that results in 90% reduction in your distribution costs. Because the power isn't traveling as far, the grid lines can also run at a low DC voltage compared to high AC voltages of normal grid infrastructure. And this keeps the grid safe to be operated on by local technicians. Our IoT controller also enables each home to be remotely controlled by the software platform. And this unlocks things like the ability to configure flexible energy and billing options, which support a bunch of innovations on the business model side that we've explored across all of our markets. Next slide. On the software side, we continue to leverage this power of IoT by using the sensor data from each IoT device to then automatically detect issues, down to really specific things like solar panel wires that need to be fixed, or maybe even suspecting power theft at a specific household. These issues can then be directly piped to a field agent who can get out there and solve outages faster. There's less revenue loss, and then tons of money is saved by not needing to send a technician out to site every time there's a problem. So all of this remote visibility, control, and data can actually result in bringing down the operations and maintenance costs by 40%. Next slide, please. All told, leveraging innovation, automation, we've seen mesh grids help our partners deploy projects at a fraction of a time and cost. This map shows one of our sites in Cambodia, where the flexibility of these mesh grids actually enabled installations on floating communities of different shapes and sizes around this river. And instead of paying through the roof in cabling alone, it's finally profitable for energy companies to deploy in some of the hardest to reach parts of the world. Next slide. So I'll end by switching actually away from the technology and towards policy just a little bit. Digitalization is, we've seen as a huge step in accelerating energy access, but to truly bring power to all people who need it, there needs to be more investment in the sector and progress in policy. So a key market to spotlight here is Nigeria. It's the largest off-grid energy market. And it's also one of the most promising markets from a regulatory and policy innovation perspective, which is really exciting. A couple things to highlight as to why that's the case. One is energy developers are allowed to set their own tariffs, which enables competition towards the best innovations. We don't see that in a lot of markets. And secondly, the World Bank, along with the Rural Electrification Agency, launched a $500 million subsidy program for off-grid energy projects, including mesh grids, which we're seeing is really helping the sector grow and support ambitious companies who are ready to hit scale. So we're excited to see mesh grids gaining traction in Nigeria and filling quite a large market gap. And I welcome anyone to reach out about that or any other questions in the discussion if you're keen to hear more. Thank you.
Thank you very much, Nithya, and we're looking forward to hear more during our discussion. And now I will pass the floor to Linda Maria. Linda Maria, the floor is yours.
Thank you, Amy. So please, you can take the next slide. Great, thanks. So I'm Linda Maria. I'm head of business development, sales and marketing in FlexiGrid, and I'm based in Stockholm, in Sweden. But so our business is a software startup founded in 2020. We are really addressing the grid-wide challenge of increased penetration of renewables, especially on distribution level. So we are truly concerned about the fast speed of the energy transition and how distribution grids actually risk becoming a huge bottleneck if they continue to be planned for and managed like they have for the last 100 years. But we see also that the distribution grids can be a magnificent enabler of a faster transition if they are properly transformed and operated efficiently and more intelligently and economically. And the way we at FlexiGrid address this is really with our solution with three key layers. So first, we really take a low voltage bottom-up approach. So we base all our solution on the low voltage monitoring and analytics platform that we can then aggregate up to higher voltage levels. And on top of that, we deploy a true distribution grid digital twin, which you can use for grid planning and also grid operations. And on top, we enable real-time flexibility management in the distribution grid, all the way to behind the meter assets. So right now we have offices in Sweden and Spain. And the reason for that is really that these two countries have two different challenges, but two very relevant challenges for the energy transition that we can help solve. So Spain has, of course, already a high amount of wind generation in the grid, but rooftop solar is increasing fast, and they see that this will actually become quite a significant problem in the distribution grid with voltage violations and tripping inverters if not managed properly. And in Sweden, there are major capacity constraints on the grid, more from the demand side, more from electrification of loads. Every second car bought now is either full electric or hybrid. And Sweden is also an early mover in terms of implementing the new EU Electricity Markets Directive, where all DSOs will have to, there will be given both incentives, but also obligations to drive towards utilizing more flexibility. So we in FlexiGrid can help the grid operators identify, for example, the true bottlenecks down to low voltage in the grid, and constraint violations to enable them to really know when, where, and how much flexibility they need to activate or buy on the market or use, like the energy storage is presented by previous speakers. You can have the next slide. So one reference project to present is the EDP Redes project that we did in northern Spain. And our solution here is built on the full integration of data from key sources in the distribution grid, like smart meters, SCADA, GIS, ERP, etc. But the really key data that we need is from the smart meters. So basically, compared to many other distribution grid control system, we based it on this bottom-up approach. And Redes is owned by EDP and covering northern Spain for electrical distribution. And we co-developed this low voltage monitoring solution, which is in operation in the grid with 650 customers. So Redes already had a high penetration of smart meters in the grid, but also quite slow communication through PLC, power line carrier, and still had really no visibility into low voltage, similar to many other distribution system operators. So they were also experiencing bottlenecks in terms of data flowing in their between their organizational silos. So they were having a very inefficient operation because of this. So it didn't really leverage the fact that we already had 100% coverage of smart meters. And with the FlexiGrid solution, they now have full visibility down to each individual household, each individual phase in the low voltage grid, meaning that they've reduced their OPEX, made their operational organization much more efficient. They reduce losses in the grid. They can identify fraud and outages much faster and much more correctly, and reducing cost for their outage management. And then the next step for them, what they want to prepare for then is to manage all this penetration of solar by deploying a digital twin to start really running the load flows and managing the grid bottlenecks and voltage violations all the way down to individual households in the grid. So I'll be happy to answer any questions and tell you more about other applications of our solution later.
Thank you very much, and thank you very much for keeping it straight to the point. So at this point, I would be happy to move on to our discussion, and starting with talking about opportunities. So of course, we would like to hear a bit more based on your work and experience, and in particularly looking at where do you see innovation in power system helping to accelerate the clean energy transition, but more importantly, where do you see opportunities for leapfrogging and for fostering radical innovation, especially looking at emerging and developing countries? So perhaps we can start with you, Linda Maria, if you can give us a very, let's say, straight to the point kind of view on how do you see things.
Well, I see one thing that we've really learned, or that we think is very important to enable a fast transition or a fast implementation of innovation, is really data. And it was mentioned before in the sort of introduction of this call and in the earlier session, how important data is. And since a lot of the solutions we have been discussing today is really deployed on the grid edge or behind the meter, having that information from smart meters, I think is such a key thing. And it's quite cost efficient to get that data. You don't have to build grid, you don't really have to build the infrastructure, you just have to deploy the meters. But and it's essential that the network operators get access to that data. But there's two things. It's both, you have to have access really to all the data. Currently in some markets we see that the grid operator has access to billing data for billing purposes, and they have to pay a lot to get maybe access to other type of data if they don't operate the meters themselves. But it's super important to have all data available, because you never know. You don't know what data, that's part of the innovation process. You don't know what data will be necessary to have tomorrow that you can innovate on, like consumption data, power quality data, event data, etc. And then the second thing is also access to real-time data. It has to be sufficiently fast, but real-time is not fixed. Real-time really depends on what type of application you want to deploy.
Okay, and this is a very important point. Perhaps like if you could summarize in one point, maybe one step that could be useful for emerging economies to implement in terms of starting to collect this kind of data.
So I think, I mean, there are different, having a full rollout, of course, takes time to get the data. So I think if you don't have 100% smart meters rollout, I mean, you can either find sort of one area where you already have better data and you can start running some pilots in that area with low-hanging fruits to understand more about your grids. And if there are no smart meters at all, but you have a plan to roll out, you can start by deploying sensors also in the low voltage side in distribution transformers or secondary substations to get aggregated data, and then start implementing some pilots based on that data, and then move into more detail further on. And if there's no low latency communication solutions, then I mean, power line carrier communication is what we work with in Spain, and it works. It depends on what type of application you want to implement. But you can absolutely start with low latency communication, implement the functions you can there, and kind of reap the benefits of these low hanging fruits to get the better insights that also makes it easier to determine what's the next investment you have to make in terms of more data or modern infrastructure to take the next more high level, implement more high level applications or use cases.
Thank you very much, Linda Maria. And of course, like this topic of scalability has come up like in some of the discussion, including in the presentation of Nithya. So like maybe I will move on, let's say, to see your perspective from the ground. Of course, like you're working with communities that are just gaining access. So perhaps like you could give us a bit of an overview of what's seeing from the ground in terms of opportunities, and if you have some specific views on how do you see, like, what opportunities do you see, for example, for leapfroggings in this context?
Yeah, thank you. I think from basically everything that we're doing, we're seeing leapfrogging in play, you know, going out to communities that don't have access to electricity, don't have really any infrastructure, but they have cell phones and they have cellular connectivity. That is a huge example of leapfrogging, just the way that, you know, they're already digitally connected before they're connected in ways that many people in kind of developed countries progressed. So, and then when we compare kind of the energy infrastructure that we are rolling out in these communities, it looks so different to, and we were just kind of building off of what Linda Maria was saying about access to data. You know, we're starting with smart infrastructure that's being put out into communities that have never had any infrastructure. And I compare that to the grid and kind of the data availability that my family had grids back in the States or in Australia. You know, they see one number at the end of the month and that's their energy bill. And instead we can look at, you know, this incredible data of how consumption is going, how that plays with renewables, and then a lot of AI automation that can be integrated. So already, you know, the way that we're combining IoT and automation into just the practicality of deploying an asset somewhere that's going to take like 2 days to reach, you know, it has to be smart and powered by data in order to be feasible. So I think one of the really big opportunities that supports this is in making sure that there's good connectivity in all of these parts of the world. So I mentioned in my presentation that we've reached about 99% global connectivity, and we've personally leveraged, you know, 2G connectivity in many areas as we can, but there's still a lot of parts that are the hardest to reach, parts that don't have electricity and also don't have data. And we're looking at, you know, ways that we can provide Wi-Fi at the same time as electricity. And this is where innovations like Starlink and other ways to get internet access out are so huge, and having a lot of startups able to deploy their smart technology and start providing opportunities to these parts of the world. So I see that as a huge opportunity to really unlock kind of the last segment that we haven't been able to reach.
Okay, great point, Nithya, and especially like on this topic of connectivities, perhaps we can go back, let's say, to this point in our discussion later on actions. And I would like to give the floor to Rayon now. Of course, like in terms of your operation, like it seems you're acting mostly like in Korea. So I guess like the laying foundations are there, but of course there are also like new experimentations and challenges that you've been facing. So yeah, if you could give us, let's say, your view from the ground and perhaps some suggestions on what emerging and developing countries, where emerging and developing countries could draw, let's say, or leverage opportunities.
Sure. So many of the challenges are, I think, coming from the fact that DERs are mostly located in the behind of the meters and cannot be seen and controlled by the grid operators, unlike huge fossil fuel power plants. So this can be a very good opportunity for a startup like us, making virtual power plant, aggregating all these behind metal, like small DERs, all together, like a scatter across large region, and provide various grid services. And also advanced optimization algorithms enables these virtual power plants to deliver values to DER's owner while maintaining grid reliability. For example, in my Jeju case studies, Jeju Island case studies, we launched this EV2 grid service, so-called Sky Blue service, early last year. And at the end of 2021, last year, we were able to aggregate more than 600 EV chargers to participate in this program, like demonstrating that EVs can serve as a reliable and flexible grid assets, which could eventually save money for both the system operator and EV owners. So these new challenges can be really new opportunity for startup like us to, develop more exciting business models.
Thank you very much, Ryan. And last but not least, Rahul, of course, you've been working in a challenging context, which is India, and you already showed in your presentation what are some of the issues that you're trying to solve. So perhaps from your perspective, once again, how do you see this kind of innovation actually supporting the power system to accelerate the clean energy transition, and if you see some specific opportunities in leapfrogging in your segment?
Yeah, thanks. So the case which I have presented for power system here in India, there are multiple issues are there in the power system segment, like from the transmission or the distribution or to the till consumers. So first issue is like all the infrastructure which has been built inside the cities are older infrastructures, and there is no access to actually redevelop or augment that infrastructure. Second is like there are some utilities where you get the data, but some utilities they don't have the data. Third is like there are a lot of and the communities which are in India or the cities which are not planned greatly, and due to that there are a lot of mix of loads are there at one point. So there are industry, there are commercial, and also the residential. So that makes that problem even more worst. So the distribution transformer, which is actually supplying power to the loads, that loads are not segregated. Those loads are not pure residential. Those loads are not pure commercial. Those loads are not pure industrial, right? That's why there is a pure play case comes in for any digitization of that system and convert into a flexible loads, flexible generation. So right now, there are a lot of things happening in India in power systems, like consumers are going, like utilities are converting consumer meters into smart meters. Then utilities are also getting a data on the transformers, on other stuff. So there is a case that you can actually have a small distribution based energy storage systems, which we have deployed and which is solving most of the challenges in the distribution segment, and also helping distribution company and the transmission company to collect all the assets on the top, and guide one software can guide all the assets as a flexible generator as well as flexible load, so that whatever the problems are they are facing till down can be resolved at a time. That's why all the utilities in India are now thinking on that and as we have installed one system, we have now get many inquiries for installation of other systems in India as well as in out of India. And government are also pushing for the regulations are also coming in this segment.
Yeah, this is an important point to raise, and perhaps like we can move to the next part of the discussion, because as we saw like in the presentation from our IEA colleagues and Catapult, there are some encouraging examples, and as you were mentioning, things are evolving in India as well, but perhaps more should be done actually to support innovation, and challenges are still there. So perhaps if you could choose your top 3 actions, policies, or regulatory changes that would be needed to support organizations like yourself and the innovation ecosystem to advance on power system modernization, what would those be?
So first thing which regulatory people or the department should do is to get the flexibility in the tariff, because there are a lot of rooftops are coming on ground. There are a lot of flexible loads are coming, but there is no regulatory so that consumer can actually make some money out of that, right? So there should be a dynamic pricing. That's the first thing is needed. Second thing has to be like there is no clear cut like regulations on how the energy storage or how the electric vehicles and how those been used in the power system, where exactly those to be used, because those are all coming inside the crowded areas or the load centers. So policymakers can make that a stipulated particular zone in order to convert that into a proper flexibility. Because the wires are just one wire is defined, but if you're putting a lot of flexible load on that side, but that doesn't mean anything. If you're putting up those flexible load in a proper way, so proper design has to come from a policymaker so that everyone will follow that design so that to make it an impactful.
Yeah, thank you very much, Rahul. And I think there are a lot of similarity among the different countries that are starting like to face these kind of challenges, not only India, but for example, like I guess Korea and others as well. So if I can hand it over to you, Rayan, what would be like the top 3 actions, policies, and changes that would be needed? And if you have maybe some specific suggestions or things that emerging economies or countries that are starting this process could be prioritized or look at first. Thanks.
Okay, thank you. So there are many opportunities for startup in the current power system transformation era, but there are still areas that needs to be reformed. First of all, there are still barriers existing for distributed energy resources to enter the energy market, including wholesale electricity market and ancillary service market. So I believe that DERs could participate across different markets and offer various services that would increase flexibility in power systems. However, the current energy markets are designed primarily for traditional energy resources, since it was created before new forms of DERs were developed, and they do not recognize the flexibility of like such as new technology like energy storage and EVs. So this needs to be updated to encourage the deployments of these uniquely flexible resources. And another thing can be the monopoly energy system that can be also found in many developing countries. In Korea, KEPCO, a state-owned company, has a monopoly over basically like whole cycles of like electricity systems, from transmission, distributions, and retail sale of electricity in Korea. So there can be many exciting business models practiced in especially in retail side. However, KEPCO's monopoly over the retail business, in which consumer can only passively accept power services from state-owned company, can be a barrier for other startups to enter this area. So I think this monopoly structure needs to be has to be reformed. And lastly, I think lack of transparency in energy markets, meaning that limited data access to private sectors. By data, I mean reliable information about real-time and up-to-date transmission and generation and pricing data. The problem is that the data is incredibly hard to reach or even unavailable. So electricity is a dynamic commodity where supply and demands are constantly changing. So a better view of pricing, bidding, grid data, and generation data and load data could allow startup like us to be better informed and therefore make better quality decision and even more exciting business models.
Thank you very much. And we see because I seem to understand that, of course, data access and data is a big, let's say, it's an important area that is necessary, let's say, for you to start and to expand, let's say, your innovation, your business models. But also, I mean, what you're seeing in our analysis that there are still a lot of barriers, as both Rahul and you were mentioning, like in terms of access to markets, and this is actually very important to unlock. Thanks, Laura, for the suggestion. And it seems that actually, like in the UK, with the number that EVs that they're expecting by 2030, for example, if rightly, let's say, unlocked, this could correspond to two nuclear power stations in terms of the support to the grid that could be created there. So huge potential, but of course persisting barriers. And if you can move on to Nithya. You were also mentioning topics of scalability, etc. Is there something that government could perhaps do to support this, especially maybe in terms of a grid connection in the future if needed, or of thinking of different, let's say, ways to manage the grid moving forward? And yeah, as I mentioned to the other panelists as well, perhaps like your top three priority list in terms of action policies and regulatory changes that would be needed.
Yeah, so yeah, there's definitely many things that we would love to see from a regulatory perspective. I think if we had our pick, some of the top things the first one would definitely just be kind of removing a bunch of the kind of rules and stipulations that technology has to look a specific way in order to be deployed as energy infrastructure, and just kind of letting the free market do its job in many ways. So the way that the market distorts and provides barriers and subsidies that basically heavily promote old technologies really make it hard for new technologies to enter the scene. And even if they are kind of better leveraging current technology, cheaper, better for the environment, they could be so much better, but the whole market can skew against them. So that's a big one, making sure that the kind of regulation isn't making it making superior technology come across as inferior from a kind of economic perspective. Another one that we see, so one of the big barriers to scale when we work with energy companies around the world is that they see the benefit of the tech, they're excited about a new innovation, but really mobilizing capital to deploy at scale, even though the business model is going to work out and they're going to earn their money back, finding that capital up front is a big problem. And we're looking at a bunch of different financial innovations to make that happen. One thing that comes in the way is rules around kind of foreign investment and ownership in these types of infrastructure can limit where where funds can come from. And when we're trying to just mobilize money to get people access to electricity for the first time, these sort of blocks are quite frustrating to really, and quite substantial barriers to scale. And then kind of along the same line of making it easier to get that upfront capital, I mentioned this in my presentation, but things like the subsidy program that we're seeing in Nigeria are really game changers for energy companies that have skills on the ground, they have the ambition, they have the ability to go out and reach the hardest to reach parts of the world, but they don't have that upfront money. And so a subsidy that can bring down that upfront cost and make it, make it actually feasible for them to deploy energy infrastructure is really exciting, and we want to see more countries that actually do that. Realistically, a kind of a stopgap approach to some of those solutions can look like, okay, where is the grid not likely to extend in the next 5 years? Because to be like, a lot of countries get stuck saying like, we just want to do grid extension, but that doesn't actually make sense for so many parts of their country. And so if we can isolate where the grid is not the economically desirable choice, and then open that up to other types of technology and lower these kind of stipulations, I think we could see some really sizable change at a very fast pace and get people access to electricity quite quickly.
Yeah, thank you very much, Nithya. And yeah, like this idea, like, first of all, like the barriers in capital and investing, like this is one of I would say like the main challenges that we're also seeing, looking at what's happening, let's say, at the global level. But also you identify a good point in which like government could perhaps identify like areas in which the grid will not get, and think about different models there. And this kind of resonates quite well with what Linda Maria was saying as well, like in terms of, identifying low-hanging fruits or areas that could be targeted with specific, let's say, actions or technology implementation. So perhaps like leaving the floor to you, Linda Maria, based on your experience and what you're seeing, like what would be your top 3 pick? And if you have perhaps like, a word of wisdom or some advice for countries that are starting, let's say, in the process and might not have, let's say, smart meters implemented.
Well, I think we are working a lot with the distribution system operators, and the whole challenge here is because of the regulated and monopoly, where they are organized. Sorry, my lights turned off. So here we think it's super important that regulation really provides the proper incentives as well as the mandatory requirements for the grid operators to drive a change. And that's including the regulated return for the grid companies, the grid tariffs, really demanding transparency in grid planning and developing, because I don't think that the most of the grid operators will change unless they have to, because that's the way they have been managing the business for so many years. They just follow the regulation. And also to remember to include the small system operators, because in some geographies there are hundreds of small distribution systems, and they will have the same challenges as the large ones, but they don't have the same muscles and they don't have the same resources to drive the change, but they can be super strategic and important for the local communities. So they also have to be able to tag along on this, on the big ones, and so they having that dialogue with the regulator and the small and the big ones to both put the incentives and requirements in place, but also educate and help the smaller ones to implement same sort of solutions as the big ones. And number 2 is really standardize everything. Also to make it easier for the small ones, system integrations, markets, data, to speed up the adoption of new solutions, and also give clear conditions to nurture the growth of these new aggregators or service providers to provide, because there has to be a stable business case, and there cannot be 200 different markets for local flexibility. This is super important that that's standardized and take the learnings from where you already tried it and just implement it ASAP. And thirdly, I think this is not regulatory, but more of an organizational and culture one, maybe a pledge to the utilities to realize that if you're going to drive this change, you cannot give it to your chief digital officer or just your technology department. It has to be driven top down, because this is a big change in culture and in resources and how how you manage your organization, because this is going to require the whole new people and competences and division of responsibilities that is not there today. And this is something that we get questions a lot, like, okay, so who in our organization are you targeting? Who's going to own this system? And we say, well, nobody, several in your current organization, but you will have to change to get the proper fast transformation and implementation of digitalization.
Yeah, thank you very much, Linda Maria. And also like this topic like of cultural change and operational change is also a really important one and has to be included in the picture. So unfortunately, I'm conscious of time. We are running towards the end of our meeting. The discussion has been really productive and interesting. We could talk about this for hours, and we hope that this is just a start of a dialogue, and perhaps we'll have some useful and interesting follow-up in the future. So I will now hand it over to Vida for the concluding remarks. Thank you all.
Thank you so much, Amy, and thank you to our panelists and to our speakers. Listening to you, what struck me, I could listen to you for hours. There's some really excellent insights, very valuable direction and information that you've been able to share with us even in this very short period of time. From our side, we will be continuing to work in this area. We'll have a discussion also this afternoon. And you've definitely given us some great ideas in terms of follow-up on what could be some of the further topics that we can pursue when we are working on developing our policy guidance, where we will be targeting what emerging economies can do to leverage these opportunities. What are some of the initial steps, the next steps that can be taken? And so everything that you've provided to us today, hugely useful. We've got positive comments also from our audience. We will be sharing all the presentations as well as the recording, which will be available online. So expect more people to have the opportunity to take part in this discussion. And as I said, this is an initial discussion, and we'll definitely continue looking into this topic area and creating opportunities to share best practices across the topic area and to hear from the very exciting people that are on the front lines of things. So again, thank you so much. And thank you to our participants, as well as to my colleagues, Etienne and Sarah, who have been supporting us, as well as Amy, who organized the whole event and did a excellent moderation of the session. So thank you, and have a good rest of the day.